In this video, I'm going to explain about the end-to-end automation. Until now, we have learned about the data-driven automation and also task-based automation. Now we are learning about the end-to-end automation and also its use cases like migration, configuration, provisioning, and also testing. So far, we have described several use cases and scenarios, but all of them have focused on single task or components. You know that a network is an ecosystem composed of many different platforms, pieces of vendor equipment, systems, endpoints, and so on. When you need to touch several of these components, in order to achieve a goal, you can use end-to-end automation. End-to-end automation can be complex because different components might have different ways of being accessed, as well as different configurations and metrics. Do not let this put you off. Just tread lightly. End-to-end automation is the most rewarding type of automation. The first question is, what end-to-end automation is? End-to-end automation is not a unique type of automation, but a combination of data-driven and task-based automation. It can also be seen as a combination of several use cases of the same type. It is called end-to-end because its goal is to automate a flow from a service perspective. The majority of the time, your needs will fall within this category because data-driven and task-based automation are the building blocks for an end-to-end flow. You do need to understand those types as well. This figure shows the topology used in the following example. In this topology, to configure a new layer 3 VPN service, several components must be touched. LAN router or switch, CPE router, P router, and also P routers. All of these components can be from the same vendor or they can be from different vendors. In addition, they can have the same software version or they can have different versions. In each of those components, you must configure the underlay protocol, BGP, route targets, and so on. This would be considered an end-to-end automation scenario. Think of an end-to-end process you would like to automate. Break it down into smaller data-driven or task-based processes. Your automation job will then be much easier. About the end-to-end automation use cases, all of these use cases described in this video are real-life use cases. They were implemented in companies worldwide at different scales. All of the use cases discussed so far in the previous video could potentially be applied to an end-to-end scenario. For example, monitoring an entire network, running a compliance report of all devices. Let me to explain first about the migration end-to-end automation. Migration either from an old platform to a new platform or with a hardware refresh are often time-consuming tasks, and some consider them to be a dreadful activity. They are complex and error-prone, and most of the time, migrations impact business operations. Automation can help you make migration smoother. Consider the following scenario. You need to migrate end-of-life devices in a data center to new ones. The new ones are already racked and cabled and have management connectivity in a parallel deployment. There is a defined method for carrying out the migration. Let me to review them. Step 1. Collect all device configuration. Step 2. Create new device configuration. Step 3. Execute and collect the output of the pre-check command. Step 4. Configure new devices with updated configuration. Step 5. Execute and collect the output of post-check command. And step 6. Shift the traffic from the old device to the new device. Step 7. Decommission the old device. This is a fairly straightforward migration scenario, but depending on the number of devices and the downtime accepted by the business requirement, it might be challenging. An engineer would need to use SSH to reach each old device to collect its configuration, make the required changes in a text editor, use SSH to reach each of the new devices, configure each device, and verify that everything works. Then the engineer can shift the traffic to the new infrastructure by changing routing metrics on other devices and verify that everything is working as expected. You could automate steps of this process, and in fact, you have already seen example of automating these steps. First, collect the old configuration. Second, generate the new configuration. Third, apply change on the devices. And fourth, verify the configuration or services. Remember that migration are often tense and prone to errors. Having an automated step-by-step process can mean the difference between a rollback and a green light, and it can help you avoid catastrophic network outage. A rollback strategy can be embedded into an automated process and automatically triggered if any check pre or post is different from what is expected. Now let me to explain about the configuration. Actually, I covered a configuration use case earlier in the task-based automation. Okay, when we looked at task-based automation. However, it is important to highlight that end-to-end configuration is just as valuable, if not more so. Okay, automating service configuration involves a collection of automated tasks. Instead of simply configuring a VLAN on a list of devices, say that you want to run an application on a newly created virtual machine and enable it to communicate. Using the data center topology that you can see in this figure, you need to take these steps to achieve the goal. Step 1. In step 1, create a virtual machine component A. Step 2, install the application. Step 3, configure layer 2 networking component B. And step 4, configure layer 3 networking in the component C and also component D. These steps are simplified, of course. In a real scenario, you normally have to touch more components to deploy a new virtual machine and enable it to communicate in a separate VLAN. The complexity of the configuration depends on the complexity of the topology. Nonetheless, it is clear that to achieve the simple goal of having an application in a private data center communicate with the internet, you require an end-to-end workflow. Achieving this manually would mean touching many components with possibly different syntax and versions. It would be challenging. You would need to know the correct syntax and where to apply it. An end-to-end automated workflow can ease the complexity and reduce human errors in this configuration. You would define syntax and other characteristics once when creating the workflow, and from then on you could apply it with the press of a button. The more complex and extensive a workflow is, the more likely it is that a human will make a mistake. End-to-end configuration benefit greatly from automation. The next use case is the provisioning. As mentioned earlier, automating provisioning of resources on the cloud is key for taking advantage of cloud technology. Most companies do not use a single cloud but a combination of services on multiple clouds as well as on-premises devices. Using more than one cloud prevents an organization from being locked to one vendor, helps it survive failures on any of the cloud, and makes it possible to use specialized services from particular vendors. Provisioning resources across multiple clouds is considered end-to-end automation, especially if you also consider the need for the services to communicate with each other. Provisioning multiple different resources in a single cloud, as with a three-tier application, would also fall within this end-to-end actually this end-to-end umbrella. Let's consider a disaster recovery scenario. Say that a company has its service running on an on-premise data center. However, it is concerned about failing to meet its service level agreement SLAs if anything happens to the data center. The company needs to keep actually its cost low. A possible way of addressing this scenario is to use the cloud and automation. The company could use a provisioning tool to replicate its on-premises architecture to the cloud in case something happens to the data center. This would be considered a cold standby architecture. The company could also use the same type of tool to scale out its architecture. If the company has an architecture hosting services in a region and it needs to replicate it to more regions, one possible way to do this is by using a provisioning tool. A region in this case refers to a cloud region, which is cloud providers' presence in a specific geographic region. Remember that when we refer to the cloud, it can be a public cloud or a private cloud. Provisioning use cases apply equally to both types. The next use case of the end-to-end automation is testing. Like migration, testing can be end-to-end composite use case composed of different tasks such as monitoring, configuration, compliance verification, and interaction. Also, like migration, testing can be automated. By having automated test suites, you can verify the network status and the characteristics of the network quickly and in a reproducible manner. Network testing encompasses various categories, include the following: functional testing, performance testing, disaster recovery testing, and security testing. Functional testing tries to answer the question, does it works? And it is the most common type of test in networking. If you have found yourself using ping from one device to another, that is a type of functional testing. You use ping to verify whether you have connectivity, that is, whether it works. The goal of more complex types of functional tests may be to verify whether the whole network is fulfilling its purpose end-to-end. For example, you might use traceroute to verify if going from device A to device B occurs on the expected network path, or you might use curl CURL to verify that your web server are serving the expected content. Performance testing is focused on understanding whether something is working to a specific standard. This type of testing is used extensively on WAN links, where operators test the latency of all their service provider links. Another common use of performance testing is to stress a device to make sure it complies with the vendor specification. About the disaster recovery testing, actually disaster recovery testing consists of simulating a disaster-like situation, such as a data center outage, to verify that the countermeasures in place occur and the service is not affected or is minimally affected. This is more niche use case because you wouldn't test it if you didn't have countermeasures in place, for example, a dual data center architecture. Finally, security testing is another common type of testing in networking. The goal of this type of testing is to understand the security status of the network. Are the devices secure? Are any open ports? Is everything using a strong encryption? Are the devices updated with the latest security patches? Although all the tests described previously can be done manually and have been handled that way in the past, moving from manual testing to automated testing increases enterprise agility, enabling faster reactions to any identified issues. Consider a system that periodically verifies connectivity to your critical assets, for example, your payment system or backend infrastructure, and that measures delay, jitter, and page load times. When you make a network change, such as replacing a distribution switch that breaks, the system can quickly test whether everything is working and allow you to compare the current performance against previously collected data. Performing these tasks manually would be error-prone and time-consuming. Advanced automated testing system can trigger remediation actions or alarms.